Pandas. This Python package is essential for you if you want to work in data science or you handle big data. Data comes in structured forms created as tables. We generate them in various ways like Excel sheets, plain text, etc. This is the third part of this series and the last part. Data structures. Data comes in structured forms, and under Pandas you have these three types of data structures. In my earlier two lectures I discussed about series and data frame. In this I will discuss about how data frame can be useful in handling big data, real data, and then we'll discuss something about, we'll give demonstration about panel. Well, big data as data frame. Okay, suppose you have a data source. It is a real data. Go to this site data.humdata.org and you see this is about this current crisis of coronavirus. This is raw data there. If you go to the site and see, and you can download the files, and the files are basically CSV files. What is CSV? CSV is comma separated value. This is very popular form, and you have some modules in your Python, basic Python, to handle this data set, this kind of data. And what you can do is that you downloaded the data from there, and this data is basically an Excel sheet, a spreadsheet. So you may not have to read all those written here, but basically it is a tabular form data, and you know there are columns A, B, C, D, all these columns, province and state, countries, latitude, longitude, and the rest are the dates, and under which there are the occurrences, daily occurrences of COVID-19, these confirmed cases. Well, suppose you have got this huge data set. What you will do with your Pandas data frame? Okay, so first what you have to do is that import Pandas as PD, as you know. And it is a good practice that you always check, once you import a package or a module, you always check what is there inside. So the basic function is dir directory. So you see what is there in PD. So it will give you a huge list of things. Among them there are many functions, there are many modules, some parameters, etc., etc. In them I have highlighted here read CSV. This is a function. I will use this here, and also you can use read Excel. This is also useful. I will not go into this, but you should know that this will be useful for you if you want to create Excel sheet from here, or you can deal Excel sheet. Also, Excel sheet here is basically a CSV file, so you can handle this with this function. And it is a good practice to know about, again, any function, to check what is there inside, what can be the arguments, what can be the keyword arguments, what are the usages, and what are the options and examples. Everything you can see here. So if you type help, inside that if you write pd.readcsv, it will give you something, how to use, what are the things, and so on. I'm not showing it this here. Okay, suppose you have downloaded the data from the site I have shown, and the data is in my computer, and the path name, you give the path name here under this quote unquote c:\users Abhijit downloads, and the file name is time_series_2019 -ncov-confirmed.csv. So this is the file. So with path name, So with quote unquote, you give this as argument inside this pd dot read csv, and so thus you read the csv file, and now you will see what it does. So rename this as, assign this as some name variable, say df. Okay, let us see now what df is. If you write this, type is a very common function. You can test any object in Python with this. So write type, within this you write df. It will show that it is a data frame. So you now know that the data you imported is basically a data frame. Well, you can see the data in full, but this is useless because the data is huge. It's a big data. So basically what you can do is that you can use some methods. One method is head. That means you can see the head of the data. That means if you, by default lines, so if you write df.head, it will show you 5 lines, means 5 rows. So the numbers you see, these are the 0, 1, 2, 3, 4. You have seen in data frame that these are the indices automatically given, by default given, and the columns are given in the file itself: province or state, country, latitude, longitude, and the dates. The dates begin from January here, it doesn't show, and it ends up to 23rd March in this particular data file. This is for example. You can deal with any current data file, and you can extract a particular row or column, and can plot and can see and can do modeling. Okay, and it is also showing you this data is here it is 5 rows, and the columns are 66 columns. That means you can understand, discarding these 1, 2, 3, 4 columns, you have actually basically of 64 columns. That means the data of 64 days. Lots of information you can get through the methods on data frame. Well, suppose now what you will do with this data frame. To handle the data frame, the better you can do is that you are quite familiar with NumPy arrays. So what you can do is that you can convert the data frame into a NumPy array. So for that you have this method to_NumPy, and if you attach this with df dot, that means it becomes an attribute to it, and then it's a function, and so then you rename it or assign it with a variable, say L. So now if you type L here or print, you see it shows you a kind of array. What is this array? Inside this array, NumPy array, you have one square bracket, another square bracket, 2 square brackets. That means without going further, you can now tell that this NumPy array is 2D NumPy array. Okay, and it writes here dtype equal to object. Okay, because there are different kinds of entities. Some are strings, some are numbers, and the numbers can be integers, can be float, whatever. Some are long integers and so on. Okay, so you can again write the type. Inside that you can put L, and you can see this is NumPy array. You can also check its shape, L.shape, and it is 501 by 66. That means in the original data you have 501 rows and 66 columns. That means there are information for 501 countries or regions. Well, now I'm not going into more into that, because once you can convert the data frame into your NumPy arrays, then it is an easy task for you, because you know how to handle NumPy arrays. Here, for example, you create a text file. So it's a plain text. You can open a text editor in your machine and you can write a file and say the file name is test.dat, for example. And suppose you write this. This is a CSV file, and you see the names I have written: city, petrol, diesel price, tea price, and the names of the cities, etc., etc., etc. I have nowhere I have given inverted commas. Nowhere I have treated them as strings. Python will treat them as strings, but when I write in a CSV file, I don't have to write like a string. I just write straight away. These are the names and these are the numbers. That's it for me. So this is a plain table for you, and it will treat the first row as the headline and the rest are the data. So this is the text file. You have created a very simple text file, and now the task will be I will read this text file through my Pandas machinery. Well, so the data was here in my directory, so I didn't have to give a path name. So I created through Python this mechanism, this Python idle this file creator. I have done that. So it is I write pd.read csv and the file name, and you rename it as you assign this as a variable, say df. And so what df does, let us type. It shows you the data file, and you see it is basically automatically it is converted. It has converted this as a data frame, and in the data frame, you know, the indices it gives automatically by default. So indices, since I have not imposed any index here, so the indices are by default 0, 1, 2, 3, 4. So 6 rows, and this is treated as headline, and these are the columns: city, petrol, diesel, and tea, etc. So here is your data, and then again you can the same thing you can do that we did earlier. We can convert this data frame into NumPy array or to a list, and then we can deal whatever the way we want. Okay, and you type df here, and again you see this is a data frame. Well, panel. So this is another third kind of data structure, which I'll tell you this is not often used. The most popular is the data frame, but still for the sake of completeness, you can have a look. Well, panel is considered as a 3D container. 3D container means it is a box, and 3 dimension means you have 3 axes, and the box has 3 axes. And you know, in the NumPy arrays, 2-dimensional, 3-dimensional, 4-dimensional, any n-dimensional arrays, the arrays are referred as with axes. Okay, so panel is a 3D container, and the data frame, since it is a 2-dimensional, it is a table, so it is a 2D container. 2D container means it is a 2-dimensional, and so when you convert this data frame into NumPy array, it is a 2-dimensional array. So it has 2 axes, panel has 3 axes, so that means 2D container or a 2-dimensional sheet or a plane can be contained in a 3D container. So data frame can be contained in a panel. And series has only 1 axis, so rows, and so it is 1D. So series can be contained in data frame can be contained in panel. So this is this hierarchy. Well, but remember, this panel is not there in Python 3 version. So whoever using Python 3 need not go through this, but for the sake of completeness, you can check the demonstration. Well, so suppose I create a data through some means. So it is our data, and it is a 2-dimensional array, and I feed this data inside this pd.panel as an argument. So if I type p, it won't show the data panel because the panel is 3-dimension, so it cannot show you, but it will show the information about the axis. So it has said that the dimensions is 2 items into 3 major axes into 4 minor axes. So 2 by 3 by 4. Basically, this part, the first is 1, this 1, and this is 2. So this is 2 items. One item, one matrix, and another matrix kind of thing. So 2 items. And 3 is 3 major axes. You can see this is major axis. The first row, second row, third row. So 3 major axis means 0th row, first row, second row. And the 4 is 4 minor axis means 4 columns. 1, 2, 3, 4 means 0, 1, 2, 3. So 4 columns. That means 3 rows, 4 columns, and 2 such things. So this is the information about dimensions. Items axis. So it has the indices are automatically 0 to 1 because if you see this part is 0 and this part is 1. Major axis information 0 to 2, 0, 1, 2, of course 0, 1, 2 because this is 0th, this next row is 1th and this is 2th and so on. And the minor axis is 0 to 3, that means this is 0, 1, 2, 3. So this is all about the information you have. Now what you have to do is that you have to extract information along the axis, following the axis. Well, so if I write p dot measure underscore xs, so about major axis and the 0th item, so it will give this tabular form. It is basically a data frame. You see, these are the rows index and these are the column indices. So automatically given. If I write p dot minor underscore xs, so along the minor axis, I want the item number 1. So it will show you another data frame. So you see the data frames can be taken out, can be extracted from the panel one by one following the axis. Well, if I write index equal to a, b, c, that means I am imposing the indices. Well, and you write this data as a dictionary. See, it is a dictionary. And in that, there are 2 items. One item is, the key is A, and the value is in the form of a data frame, pd.dataframe. And I create the numbers through numpy.np.random, random number module, random module. And there the function or the generator is rand, which will create random numbers between 0 to 1, and this will be 3 by 4. It will create a 3 by 4 array. Similarly, you have, and then you put comma index. So index is this. Then you have key B, and corresponding similarly the data frame is this. Similarly, this is a for demonstration purpose fake data I'm creating. Okay, and now you put this data inside this pd.panel as an argument. So this is your P. Now if I type P, it will show you again the information about the axis that it had shown earlier. Only difference is that since you have put here the index A, B, C, so it will show you that the major axis indices are changed from, now it is from A to C. Rest are all, they remain the same. Methods on panel. Like methods means functions, particular functions applied for these special functions. So the methods, you see the methods are very general thing. You see applied methods on lists, methods on NumPy arrays, methods on Pandas series, data frame, and now the methods on panel. More like the same thing. It will give you, it will manipulate the data inside. It will give you the indices. It will slice. It will give the information about axis and so on. Well, if you write p dot values, so it will show you the values, because otherwise p is now your panel you created just now, and since p will not show you the data, actually it will show you the information about access. So if you write p dot values, it will show you the data. So you can find out the access here. So this is A, this is B, item A, item B, because that way you created. This is your 0, 1, 2, 3. these columns, and these columns are you have created with the indices A, B, C. Similarly, this is also A, small b, small c. So this is the three different axes. Well, if you write p dot access, of course, it will show you the information about this. Don't bother about this U here. U is Unicode. U A U B. It will show you the some about the elements in the index of the access. Well, if you write p dot size, of course, the data are 2 into 3 into 4 form. So the total number of data points will be 24. 2 into 3 into 4. So the p dot size is 24. If you write p dot ndim, n dimension, because it is 3-dimensional array basically, so the dimension is 3. And if you write p dot shape, it will be 2, 3, 4, of course. If you write p dot measure access, and in terms of the names of the rows, you give A here, it will show you this. It will write in a different way, A column, B column. It takes from the A part, it takes from the B part, and these 0, 1, 2, 3 are the four, you had the four columns there. Now here it writes in a way that these are the 4 rows. Basically, this is a data frame, as I said earlier. If you write p dot minor access 1, of course, here you call through the name, here you call through the indices. Rest are the same. And this is major access information, this is minor access information. In a similar way, you will see here it will write ABC, small ABC means all those 3 rows and 2 items A and B. You check with the original data, type on your interpreter and check. Well, and if you write p dot sum, that means you want to have sum of the elements along the axis 1, 0 axis, 1 axis, 2 axis. So it will sum individual axis wise, and for the item A, for the item B, for the rows A0, 1, 2, 3 and so on. If you write p dot sum 2, similarly it will be along the axis 2. Well, this is the end of Pandas 3 and this is the end of this series. Thank you.